Hi guys, welcome to my channel again. My name is Malasa. Today I'm gonna be show you the proceeding modeling parts of the Ethiopian history building. In the previous tutorial, we have already seen the complete modeling parts of the uh, Ethiopian history building using etabs 2016. Now, today we'll proceed to the remaining modeling part, which will be focusing on the assigning of piers and spandrels to the shear walls and the assigning of the diaphragm to the slabs. And also we will see the assigning of the mesh to the walls and as well as to the slabs. Now let's start. So here this is the model that we have already modeled in the previous tutorials. So this is the shear walls. So here you will get more updated tutorials in the future. So in order to get an updated videos and tutorials, you need to subscribe my channel. And also, if you like this video or my videos, you can share to your friends. And if you have also questions and comments regarding to this uh, project, so you can give me comments in my comments inbox. Now let's proceed to the today's tutorial, which is the tutorial part number 6. We'll be focusing on the assigning of assignments to the shear elements. Okay, here this is the shear wall. Uh, now let me show you how to just a model opening on the shear walls here. This is now let me delete it for the sake of showing you how to just model an opening on the shear wall. So now let me delete it. This is deleted. So for here, uh, here this is the opening. Now let me also here. Just now let me delete it also. Okay, this is already deleted, and now let me delete this joint because I have already created the joint. So here the opening is, the opening of the coral is it is 2.1 meter in height, and the width is 90 centimeter. So here the index of the top of the opening is 2.1 meter from the this point. So I need to draw a joint object uh, 2.1 meter above this point. So to do this, now let me go to the draw menu, then draw joint object. Here I need to specify the height, which is 2100 from this point in positive direction. Here this joint object is created, and this joint object is created. Now let me draw the opening here. So in order to create the opening, first I need to draw the shear wall here, which is the shear wall, or just I can draw the opening here. I can select this opening. Simply I can draw like this. Opening is created. Opening is created. And I need to draw the shear wall here. That is the wall 40. Just like this. And like this. And here, in similar manner, for the rest of the stories, uh, uh, we can draw the openings and the spandrel. This part is what we call it a spandrel. We will see later. So, or just we can duplicate this opening to the similar stories. Okay, here we need to specify also the the elements here just with a similar manners as specified in the above. So we need to draw a line here so that the horizontal uniform elements will be generated here. So to do this, we need to draw a line object here. So draw a line object here. Okay, now let me draw non-line object here. Here, this is non-line object here. So I need to draw a line here. Or just need to draw snap option. So make it the grid intersection. Okay, where is the perpendicular? The intersection, this one, in the perpendicular. So this one, and I need to draw also here, just like this. So here now let me divide this wall at the point of this line, and I need to draw also, I need to divide also this wall at this point, at this line, and I need to divide this wall also at this line, and I need to divide this wall also at this line. So here I've already selected the walls. Now let me go to the edit menu and the edit shells, the divide shells. So here now I need to divide the wall elements at the points of the frames, just like this. So here, okay, sorry. So I need to select the wall and the frames, and go to the edit menu, edit shells, and divide shells. And now here I've already selected. Now click apply. Here the shell walls are divided at the points of the frames. Here, just like this. So I need to delete the null line object. Here, the null line objects are deleted. So here, this is the shear walls at the entrance of the uh, the lift shaft. So now let me see the plan. Just like this. This is the wall. This is the core walls, and here this elevation is taken on this side. This one. Okay. Here now let me define the piers and spandrels that are going to be assigned to the shear walls. So here we have different sizes of shear walls. So we need to assign different names of the piers and spandrels. So now let me say something about the piers and spandrel first. So here, you know, so let me define something about the spandrels. Here these shear walls has two main parts. The first one is, the spandrel. Spandrel. Here, this part is, spandrel is nothing but it is the horizontal member. It is the horizontal member which is located. It is the horizontal uh, member. It is the horizontal member which will be acting as a beam. Sorry. Acting as a beam. it is a wall, but it acts as a beam, and it is located above the opening. It is located above the opening and below the floor level. Here, below the floor level and above the opening. So suppose here this is a shear wall, and this is the ground floor, for example, and this is the first floor. So if we have the entrance here, this is what we call it is door. But in the case of this, just we can divide this into this part here. So this is the opening, and this one is spandrel. This is defined in the definition of number 1. In this case, it is what we call it. It is this part. What we call it is piers. So in the case of window, the spandrels will be located above the opening and below the floor level. Okay, so having this in mind, we can define the spandrel level at the top of the openings. So here now let me define the piers. So here piers. So here piers are nothing but just are the vertical elements. Those are the vertical elements which will be acting as column. And piers starts at floor level. At floor levels and ends to the next floor level. The next floor levels or base of opening. This is the definition of the piers. So here we can see we can assign this shear wall as a piers because it starts as the floor level and in this to the next floor levels. Okay, here we can assign this the right parts of these shear walls. This one as a piers because it starts at the floor level and it ends to the floor level of the next story. And also when we come to this, we can assign this vertical shear wall as a pier because it starts at the base of the floor and ends to the base of the next floor. And similarly, this is also. So having all this in mind, we can define the piers. So to define the piers, now let me go to the define menu, and here then we need to select the pier level. So as we have different sizes of shear wall, so we need to define different names of the piers. So here we have totally one shear wall, the 2, and the retaining wall 3, and this one is 4, 5, and 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and we can define totally 20 piers. P1 at, sorry, uh, here we need to make it 2 at, so we have already defined 20 piers, and also we need to define the spandrel. So to define the spandrel, just go to the spandrel level menu and click this one. So we will have, one spandrel here. This is the first spandrel, and we can define 2 spandrel for the right part and for the left part. That is a C2. What new? Okay. So okay, uh, now let me select the shear. Just to select the shear, go to select menu and see wall. Here we need to select all the walls. So now show the selected object only. So now go to the plan view. Okay, now go to again to the wall command here. Now let me select the retaining wall. Okay, retaining wall is selected. And now assign the spandrel to the retaining wall. Here now, okay, here spandrel. Sorry, assign gears. Now here one. So now select the previous selection and height. So so now make it all story. Select this one and pier Q. And now select this wall and assign P3. Okay, this is I think all about the assigning of the piers. Now let me go to the assigning of the spandrel. So to assign the spandrel, let me view the elevation into this side. So here this elevation is B3. Go to elevation, B3. Okay, here. And so now select it, assign P6 because it was not previously assigned with P6. So here go to D6, apply, and select this one also, like P50, because the assignment is automatically assigned to the similar stories. Now select this one also, assigned with P40, and select this one and assign it with P30. Okay, what is left? The spandrel. And also the above stories. Now select it, and assign it with P60. And select it and assign it with P50. And select it and assign it with P40. And now select it and assign it with P30. Okay, now let me go to the last story. Because the height of the story is different. So as the height varies, so the selection will not be an automatic. So the selection will be automatic for similar stories. So now select it. So assign P60. So select it, assign it P50. And select it, assign it P40. And select it and assign it P30. Okay. So now let me also assign the spandrel. So as we have already defined spandrels are nothing but it is the horizontal member located above the opening. So to do this, we have to select it. So go to the assign menu, insert, and hit the spandrel. So now let me assign it S1 for the left part, and for the right part, I will assign it with spandrel 2. So now all walls are assigned with piers and spandrel. So if now here if suppose if this is a wall, now this is the elevation. If this is this is a shallow lava. So it can be drawn with visual or it can be drawn with the slab command. So it can be, etabs will automatically considers it as a wall if and only if it will be assigned with piers. If we don't assign piers to the wall, so it will not be recognized as a wall. Instead, it will be recognized as a slab, that is a vertical slab. So we need to specify the we need to assign piers and spandrel to the walls. Okay, so here this is I think all about the defining of opening and the defining of piers and spandrel, as well as the assigning of piers and spandrel to the walls. Okay, now let me divide the rest of the shear walls. So to do this, we need to select the shear walls. So to do this, go to the select menu, then go to the property command, and then go to the wall section command. So select all the walls. So show the selected objects. Here now we have already divided this wall previously, and what is left, we need to divide the rest of the walls except that of the entrance of the column. So here now let me go to the second basement. So here we need to divide the retaining wall at every 1 meter spacing. Here now select this one and go to the edit menu, edit shells, divide shell. So we need to divide it into 10. Then apply. Okay. Here now let me uh, see the elevation view to see the division of the walls. This is divided into two equal quarters, and here this one is also divided into 4 equal quarters, and the division of this was made previously, and this one is divided into 1, 2, 3, 4, 5 equal quarters. So here all the walls are divided into n number of division, so that the analysis will be accurate. Okay, now let me go to the plan view. Go to down, and now let me select all the joints and assign them a fixed support. So this is all about the division of the shear walls. So now let me go to the shells. I mean the mesh. So now let me say something about mesh. So the here the meshes. So why we need to mesh the structural elements. So the purpose of meshing is just to define the number of equations that etabs will be calculating during the analysis. So suppose this is the element. So this is, it may be slab or it may be wall. So here this member has infinite number of points within the elements. So etabs will not be able to calculate the internal forces of the members, because here indefinite number of or infinite number of pointers will lead to infinite number of equations. So infinite number of equations will not be able to be analyzed by etabs. So etabs will analyze definite number of equations and finite number of elements. So to make finite elements, as the definition firm, that is finite element method, which is the element should be finite or defined. So here we need to, for example, if this is one element, so the member has to be divided into 4 equal parts or 4 non-equal parts. So here, this, suppose we can take this element. So this element will have how many nodes? That is 6. I mean 1, 2, 3, 4, 5, 6, 8. 8. It has 8 nodes. So with 6 degree of freedom. So totally 6 degree of freedom, 3 rotation in X, Y, Z, and 3 translation in X, Y, Z. So totally 60 degree of freedom will be taken for every nodes. So 60 degree of freedoms times 8, totally will have 48 equations. So the total number of equations that etabs will calculate will be the total number of nodes multiplied by 6. This gives the total number of equations. And also the meshing by itself is the process of discretization of the member into the definite number of elements and nodes. So this is the purpose of meshing. So having this in mind, we need to assign meshes to the walls as well as to the floors. So first, here we will have 2 types of meshing. So 2 types of meshing. So we'll have 2 types of meshing. Again, 2 types of meshing. The first one is an automatic meshing, and the second one is the manual meshing. So we will use either automatic or manual method. So now let me select all the walls. Okay, now select object type walls. So now select all the walls. Then go to the assign menu. Here we have floor automation and wall automation. I can select wall automation. So here this is the default one, and here we can mesh the object by two vertical and two horizontal. But here the walls are rectangular in shape, so I can select auto rectangular mesh. So here I can define even the sizes of the mesh. But here automatically GitHub will assign the size of the mesh to the walls. Now select apply. This is an automatic meshing, and the above is the manual meshing. Okay, here to see the sizes of the meshing, we can go to here, then analysis meshing. Okay, show analysis meshing, apply. Now it is taking more time. Sorry. Okay. Okay. Now let me go to the log. Just go to the flush here. Now select. Now go to here. Then select the slab section. So we need to select all the slabs. Select. Then go to the sub menu. Here we need to select the floor automation command. So here if we let it as it is, so the floors will be meshed by the default option. So if we use this option, also the vertical and the horizontal rows of meshes will be defined by this. That is two vertical and two horizontal. And here, if we select auto cookie sketch object into the structure element, that means, for example, we can define the size of the mesh here by this option. But here we can select the default one. Or we have also other option here. Just go to the analyze, menu, and here automatic mesh setting for floors. Here we can define it. That is the rectangular mesh with this 1 meter. Or we can make it 0.5. But if we reduce the size of the mesh, then it also will take more time to analyze the structure. So we need to make it this 1. Okay. So here meshes are assigned to the floors. Okay. Sorry. So here now let me see the now let me display the analysis mesh. That is the frame here. Another assignment is now the journal. Now let me click this one and apply the to window. Now apply this one. What here meshes are displayed here. So you can see the meshes here. Simply, these just meshes are applied to all floors. So we can go to the upper floor. See, and when we come to the wall also, see, meshes are applied to the vertical walls. Those are the meshes. Now let's proceed to the definition of diaphragm. So before just proceeding to the diaphragm, now let me say something about diaphragm. Okay, here going to this. So diaphragm is it is nothing but uh, it is the diaphragm. Diaphragm is nothing but it is the connecting mechanism of joints. The connecting mechanism of nodes. So here every nodes has to be interconnected with the diaphragm. So why we provide diaphragm to the horizontal members. So the main purpose of just providing diaphragms to the horizontal member is to transfer the horizontal load to the column. To transfer lateral load to the beams and the beams to the columns. So if we don't provide diaphragm to the floor, so the lateral load will not be transferred to the column, and the center of mass will not be generated. So if there is no center of mass, so it is impossible to calculate the center of rigidity and the center of mass. So this is the first purpose of the diaphragm, and the second purpose of the diaphragm is to uh, behave, I mean to let the beams the beams the columns and the shear walls, as well as the slabs behaves behave monologically. Monologically or in integrated manner. That means here, suppose we have a column here and we have a column here, and also if we have a column here, a column here, a column here, and a column here, and all that are just assumed to be beams, and here this is the slab. So if we apply the horizontal or the lateral force in x direction, so all the members that are connected to this node will move laterally in integrated manner, not in a separated way, because this and these members are integrally connected to this joint, and finally this joint will be connected to the diaphragms of the floor. Suppose this is the diaphragm. So the main purpose of the diaphragm is to behave to let the beams, columns, shear walls, and the slab behaves in integrated manner when we apply the lateral force. That means all the nodes will be translated laterally in similar manner. And so to attain all this, the functionality behavior of the structure, we need to apply the diaphragm. Okay, here we need to define the n number of diaphragms, where n is the number of stories. So we'll have 20 stories, so we need to define 20 diaphragms. So to define the diaphragm, we need to go to the define menu, and then here we have the diaphragm command. So we need to define the diaphragm. Here, now here we have two types of diaphragm. The first one is rigid diaphragm, then the second one is semi-rigid diaphragm. So what is rigid diaphragm and what is semi-rigid diaphragm? Now let me say something about those two terms. Okay, here first now let me define the rigid diaphragm. Rigid diaphragm. So here in the case of a rigid diaphragm, there is no relative lateral displacement. So no relative lateral displacement. That means pointers at the floor level will be displaced laterally in equal magnitude. But in the case of, in the case of semi-rigid diaphragm, there is semi-rigid diaphragm. So in the case of semi-rigid diaphragm, there will be relative displacement. Relative displacement. So in order to avoid this relative displacement, or in order to make the relative displacement zero, etabs will undergo an iterative uh, analysis method. But in the case of this one, the etabs will not undergo an iterative analysis method. Automatically, the process will be set to make the relative displacement to be zero. So in the case of this one, the analysis time will be longer, but in the case of this one, the analysis time will not be longer. That means we have short period of analysis. So this is the main difference between rigid diaphragm and semi-rigid diaphragm. So now let's assign rigid diaphragm to our member in order to make the analysis time short. So here we need to define 20 number of diaphragm. So do one, add new diaphragm. So 2, Now this is all about the assigning of diaphragms to the floor levels. So here we need to uh, avoid assigning of diaphragms to the stair landing. So because stair landing is located between two-story levels, so diaphragms are assigned only to the floor levels. So we have already defined 20 stories. So we need to avoid assigning of diaphragms to the landing. So we need to select the landing, because if we run the if we check our model, there will be error. Here, warning, that is warning. Horizontal rigid diaphragm connection found between joints at different elevation. So here, this warning can be avoided when we avoid assigning of diaphragms to the landing. How to do this? Go to the select menu. Sorry. Go to the select menu. Then go to the slab command. So select landing. So assign diaphragms. So we need to avoid assigning of diaphragm by selecting none. Apply. Okay. Okay. Now let's check our analysis again. So warning, horizontal rigid diaphragm connection found between joints at different elevation. Please check it. Okay. Now let me see the error in detail. And I have to take a remedy action. That means L, that is there is an overlapping here, L13 and B46. We need to delete all null line objects. So go to the select menu, that is frame section. Sorry, the frame section, that is null line. So go to the edit menu, delete. Sorry, show all objects. That is taking more time. So delete it. So now the number of errors will be reduced. Now let's check the analysis again. Here, as I have already deleted null line object, so the number of errors will be reduced, so that I can here, as you see, the null line objects are deleted here. Previously, there are errors associated with null line object. So here at 16 story, there is an overlapping of B48 and B98. So I need to select this one. So paste in notepad. So I need to delete this one. Okay, here I need to select B48 and B98 at 16th floor. So I need to go to the 16th floor. Okay, that's 16th floor. Then that is B48 and 98. B48, it is B48. B48 select and B98. B98 select. Then show selected object. Show selected object on. So now let me select it to see here. This is the frame. Okay, now let me view the frame section that is labeled. This one. So that is B48. This is overlapped with B98. This one. Okay, so we need to delete either of one. So the 16. So I need to hide it. So I need to delete this one. Okay. So now show all objects. Here I have one member. Okay, the second one is F42 and F91. That is 90, 42, and 12. 42 and 91. So here show selected object only. So now let me make the level of shell objects to be visible. Here, this one. So this object and these objects are aligned, are too close. So I need to. Okay, so we need to merge it. Rotate shell and merge shell. So it is merged. So now let me check once the model. Okay, here there is no error. So model has been checked. No warning message will detect later. So this is all about the assigning of diaphragms to the floor and the assigning of shells, the assigning of piers and spandrels to the shear walls, and the assignments of the meshes to the horizontal member and to the vertical members. That means to the floors and to the shear walls. So this is all about for today. That is tutorial part number 6. So if you like this video, don't forget to subscribe my channel, and also don't forget sharing this video to your friends so that your friends will get more relevant tutorials regarding to the modeling and the analysis as well as the designing of this theory story buildings. So don't also forget giving me comments or questions regarding to those tutorials. So in the next tutorial, which is in tutorial number 7, we will be focusing on the definition of the loads. So I'll see you next. Thank you very much.